7. We have the expansion of 2x plus 1 over 4x power 20. If I expand it out, there will be many terms. How many terms? How many terms are there altogether?
21.
21. May not be true.
No, it's not 21.
Okay, generally it is possible to have 21 terms, but some of them may cancel out. Okay, let's take a look. We want in part 1, the term containing x to the power of 6. So I'm going to have many terms with x to the power of whatever. One of them will be x to the power of 6. I only want to zoom in on this particular term without expanding everything out. So one useful way is to use our 2x. What about b? What is our n? What is r? What's r? What is the value of r? We don't know yet. We don't know yet. Literally, we don't know yet. So I need to write down the general term. T r plus 1 equals to n choose r, but I know that n is equals to 20 lah. Okay, let's replace it with 20. Choose r, 2x to the power of 20 minus r, 1 over 4x to the power of r. Agree? This is my general term. Hey, do you see indices over here in our general term? Yep. Okay, and this part over here is simply a number. Don't fear it. It is simply a number. Okay? So because we do not know the value of r, I'm going to copy it down first. Now, in the question they say that x to the power of 6, right? How many x's do you see in this question? You see them in 2 positions, right? Wouldn't you want to combine them together? And are you able to combine them together?
No.
Why not? But you can simplify using laws of indices, right? So let's take a look. Here, if I separate everything out, I make it really easy for you. Here I've got 2 to the power of 20 minus r. X to the power of 20 minus r. Agree so far? Okay, I can put it this way also. Then I've got 1 over 4 to the power of r. X to the power of negative r. Okay, take some time to convince yourself this is correct. Is it correct?
Yes.
Who needs more time? 1/4, okay. This portion over here is the same as 1 over 4, 1 over x, power r. Agree? So I can break it up lah. 1 over 4, power r, 1 over x, power r, which is the same as 1 over 4, power r, x to the power negative r. You want 4 to the power negative r? Can. Okay? But I just prefer to put it this way lah. Okay, so now I still have my x term over here, x term over here. I want to determine the value of r so that I can find the term. Right? And then there is a condition, which is the power of x must be 6. Right now I've got x to the power of something, I've got x to the power of something. I must combine them together using laws of indices. Okay, so our chapter 1 in EMATS, very important. So this gives us 20, choose r, 2 to the power of 20 minus r. This is just another number again. And then I've got 1 over 4 to the power of r, which is again another number, which I would like to now change it to 1 over 2 to the power of 2r. Can or not? Can, right? 4 is 2 to the power of 2. Okay, then I've got x to the power of, can you fill it in for me? X to the power of 20 minus 2r. Alright? So what you guys did was to compare this part and this part. 20 from here. Okay? So now, can you tell me what is supposed to be equal to 6? You agree? 20 minus 2r is supposed to be equal to 6? Because this is my only x term. right? So this must be equal to 6. Now if I can tell you that this is equal to 6, 20 minus 2r is equal to 6, then what is r?
14, 7.
Rather, can you find out what r is? Yeah, I'm sure you can, huh? So from here on, I know that my next step has to be when 20 minus 2r equals to 6. That is the condition given to me.
So is it 6 or 9?
6. So when 20 minus 2r is equal to 6, I've got 2r equals to 14, r equals to 7. Now that I know r is equal to 7, what do you think I want to do next? Sub back in to my general term. So when I sub it back into my general term, this is what I'll get. T. Huh?
Example, when you write T r plus 1, right?
Ah.
Then if you starting like T8, right? You say general, you say like coefficient x. Sorry, term of x. Our 8 equals term 7 like that.
No, this is how I'll write it. I'll write T r. We found out that r is 7. So 7 plus 1. At the back of our minds, we all know that it's equal to term 8 lah. But that's not the point. Okay? When they say find the term containing x power 6, you better not tell me that it is term number 8. Okay? I want the value of the term. You don't tell me it's term number 8. Okay? So it is T 7 plus 1 equals to 20, choose 7. And you can choose to sub into any of these. Either your equation number 1, 2, or 3. Which one you prefer? Which one do you prefer to sub in?
First one.
I prefer to sub into the last one. Whichever one doesn't matter. Okay? Choose whatever is easier for you. So if I sub into my third one, I've got 2 to the power of 20 minus 7, 1 over 2 to the power of 14, x to the power of 20 minus 2 times 7. Please take note that I changed the 4 to become 2 power 2, right? Because I had the intention of combining them together. But you realize that you can also use your calculator here. But I want to use this opportunity for us to use our mental sums. Okay? So 20 choose 7. This one I allow you to use calculator. What do we have? 20 choose 7, press. 38760. Okay? Then I've got 2 to the power of 13 divided by 2 to the power of 14. How much is that? 1. Do you say 1? 2 to the power of negative 1, which is half. Then we've got x to the power of 6. Is it a coincidence that I get x to the power of 6? No, it is not. Okay, why did... Okay, hang on. Okay, wait. This should be 7, 7, 5, 2, 0. Is it? Okay. So now we've got this term and I have an x power 6. Is it a coincidence? No, I planned for it to happen. I made the power be equal to 6. So now I continue next step. I get 38760 x power 6. And this is the term that contains x power 6. You understand how this works? Okay. So now I want you to tell me, fine, what is the term? Find the term containing x to the power of 10. Okay, this is your job. Find the term containing x to the power of 10. For the same question, yes.
So just screw up for the equation.
No, not possible. Find the term containing x to the power of 2, for example. Okay, find this one. Do you get the same equation that I have? 20 minus 2r equals to 2. You should lah, because everything else stays the same. And it's still the same portion that contains a power for x. So 2r must therefore be equals to 18. R must be equal to 9. Correct? So here we are looking for the 10th term. So it will be 20 choose 9. Then I've got 2 to the power of 20 minus 9. 1 over 2 to the power of 2 times 9. X to the power of 20 minus 2 times of 9. 20 choose 9, how much is that? 960. Okay, 2 to the power of 20 minus 9 is 2 to the power 11. Power 11. As well as 1 over 2 power 18. So x to the power of 20 minus 18, of course, it's the square lah. Okay, so 167960. 2 to the power of negative 7. X squared. Okay, how much is this? Okay, do you all have this? All same? Same, huh? So this is a common type of question. Do you know the fraction for this? Okay. Okay, very good. Now I want you to... Huh? Yeah, leave it in fraction, please. So now I want you to find the term containing x to the power of 0. Can you do this? Term independent of x. You will see this phrase frequently in binomial theorem. When they say term independent of x, they are referring to a term that does not have x. And a term that does not have x must be a constant term. A constant term will have something like this with x power 0. So when you see this, straight away you know power of x equals to 0. So our approach is all the same. We go back to our general term. This time we say that for term independent of x, 20 minus 2r must be equal to 0. R must be equal to 10. Did you all have that?
Yes.
Okay, then from there on, you substitute r equals to 10 into the general term. So we get t 10 plus 1 equals to 20 choose 10, 2 power 10, 1 over 4 power 10. Yes? Okay, we can simplify this. It becomes 2 power 10, 1 over 2 power 20, which is 20 choose 10, 2 to the power of 1 over 2 power 10. Right? Then you use your calculator to evaluate. You will get 180, no, you leave it in improper. 46189 divided by 258. For those of you who say you get a number that doesn't end, I want you to key this fraction in and you see whether it is the same fraction as yours. Have you already forgotten how to do your long division, for example? Like, I mean, this one, okay, what is this? 20 choose 10, how much is that? 184,756. Okay, what about 1 over 2 power 10? It becomes 1 over 1024, am I right? Right? So, can't you evaluate this by yourself? This one. Isn't this the answer? Yes, right? Can evaluate ma? 184,756 divided by 1024. Divide by 2. 92378 divided by 512. Hey, divide until you get this law. Divide by 256, sorry. Cause your calculator not pro enough. No. Okay? Can or not? Anyway, this is in your textbook. It's work example, part 2. They call it term independent of x. I introduced it to you by saying it is power 0. It's the same thing. So now, practice 11. your calculator will give you an exact number in this question. When you talk about non-exact numbers, you guys are referring to, for example, okay, suppose you key into your calculator 1/3. Put it inside your calculator now. Which calculator tell you 0.666? You go and throw it away already. Okay, so this one, right, in your calculator will tell you 0.33333, right? So, my point is, if you see this, you must know you are supposed to convert it to a fraction and not leave it as 0.333 because I'll mark this as wrong. Okay? This is an example of exact numbers. Although an exact number, although your calculator shows that it is recurring. Remember this word recurring? Sec 1, you learned it, right? What about numbers such as square root 2? Key in your calculator square root 2. 1.4142135 blah 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 blah. This one, does it go on and on forever?
Yeah.
Yes, it is an irrational number. So in E maths, we will round it off to become 1.41. In A maths, we leave it as the exact value of square root 2. Okay, we don't put this in A maths, we don't put this in A maths. I leave it like this in A maths because I am very particular about the accuracy of the answer. Right? So in the earlier example, when you have a fraction a number divided by a number, I'm sure you will be able to leave it like this. Can? Okay, your turn to try. No, it was your homework. So question, practice now, 11, question 1, part 1. Find the term containing x to the power of 9. We've got x squared plus 1 over x to the power of 12. What are we required to write down first? General term. Okay, t r plus 1 equals to 12 choose r x squared 12 minus r 1 over x power r. This is my general term. I want x to the power of 9. So I need to group all my x terms together. 12 choose r, x to the power of 24 minus 2r, x to the power of negative r. Do you guys have this?
So I guess and check.
Guess and check, 0 mark. So what is the power over here supposed to be?
5.
Huh?
No.
9. Power is supposed to be 9. Therefore, 24 minus 3r must be equals to 9. 3r must be equals to 15. R equals to 5. What is the term then? T5 plus 1, which is T6, is 12 choose 5. X to the power of 9. You get 24 minus 15, you get 9. Wow, this question is so easy. So 12 choose 5, how much is that?
220.
Okay, so 220 x power 9. Yeah lah, hey, Cosby.
Oh wait, I'm taking out paper. Wait.
792 x to the power 9. Who got this by yourself at home? Homework question. Okay, then you understand already lah. So the next part, they want the term independent of x. Term independent of x. That tells us that (24 minus 3r equals to 0. R equals to 8. So I'm looking for term number 9. 12 choose 8, x to the power of 0. And how much is this? 12 choose 8, calculator? 495. That's it? Understand? Yes? Can I won't fault you. But I'll make sure that I set a question that says, for example, 1 over x plus x cubed to the power of 26. You expand? You sure you want to expand? No lah, not a good idea. Okay, let's start with x plus 1. X plus 1 to the power of 4. Okay, how does this expand? What does this expand to give us? So 4 choose 0, x to the power of 4, 1 to the power of 0, plus 4 choose 1, x power 3. Do I need to write 1 power 1? Do you want me to write 1 power 1? Actually don't need, 4 power 2, 4 choose 2, x power 2, 1 power 2. Can ignore, right? Okay. 4 choose 3, x power 3, 1 power 3. Hey, wait, I made a mistake. X power 1, okay. Plus 4 choose 4, x power 0, 1 power 4. Right? Yep. So we can simplify this to become x power 4. Okay. The next, okay, so this is 4x power 3. I hope nobody is using calculator for 1 power 3, or 1 power 1. Okay, next one. 4 choose 2. Can you do it without a calculator?
Yes.
How much is it?
6.
How do you get 6?
2 times 3. 4 times 3. 12
4 times 3 is 12. 12 divided by 2 is 6. Or you can do some cancellation, right? You get 6x squared. What about the next one? 4 choose 3. You can do cancel, cancel, but there's an easier way, right? Just mirror image 4. Then the last one, x to, it becomes just 1. Okay? Yes? You can, but it helps to train your brain, practice lah. Okay, mental sums. Next one I want you to look at is x plus 2 to the power of 4. Okay, how does this compare? 4 choose 0, x power 4, 2 power 0, 4 choose 1, x power 3, 2 power 1, 4 choose 2, x squared, 2 power 2, 4 choose 3, x cubed, x power 1, 2 to the power of 3, 4 choose 4, x power 0, 2 to the power of 4. Okay, come. 4 choose 0, how much is that? 1 times 1 times x power 4. Okay, I get x power 4 again. Next term, what is it? 8 x cubed. Next. How much? 24 x squared. Next. How much is it? This is 4 times 8, 32. 32x followed by, are you sure 1? 16. Can you see why it is like that? Because of the 2 over here. It changed such that it no longer gives you a mirror image over here. That is the effect of the 2 over there. Okay? So the next pattern I want to show you is 2x plus 2, for example, power 4 again. Okay, so we see that the coefficients are, this part, the choose is still the same. 4 choose 1, 4 choose 2, 4 choose 3. No space, no space. Will it? Okay, hang on. So I get 2x to the power of 4, 2x power 3, 2x power 2, 2x power 1, and then here I don't want to write already. So this is 2 power 0, 2 power 1, 2 power 2, 2 power 3, and 2 power 4. Okay, expand. 4 choose 0, how much is that? 2 power 4. 16x power 4. Plus 4 choose 1, how much is that? 4 times 8. 32 times 2. Another 2 here, 64x cubed. 4 choose 2, how much is that? 6 times 4. 24 times 4. 96x squared. Right? And then sure. 4 times 2 is 8. 8 times 6, yes, 64. 64x plus 16. Okay, what do you see now? Look at the powers. What are the powers like? Still decreasing. 4, 3, 2, 1, 0. Yeah, it is symmetrical again. Why? Because I can right? I can factorize out 2. So this becomes 2 to the power 4 x plus 1 power 4, which is 16 times x plus 1 power 4. Right? Then all you compare it with our x plus 1. All you need to do is to put 16, 16, 16, 16, and 16. Right? That's how you get it. Okay, probably the last one I want to show you will be 2x squared plus 2 plus 3, for example.
Are these like shortcuts?
They're not really shortcuts, but you see the pattern and how it changes. 2x squared plus 3 squared. Power 4. Okay, come. First one, 4 choose 0 plus 4 choose 1 plus 4 choose 2 plus 4 choose 3 plus 4 choose 4. 2x squared power 4. 2x squared power 3. Okay? So in this case, it is going to be different because my main point is my value of a is it has a coefficient, it is 2. At the same time, it has a power, it is squared. So this is my a. All these are my a's. So without working everything out, I would like you to tell me what is the highest power. For the first term, what is the highest power for x? Okay. So you can work it out yourself. This one, the power will be? Power? And then x power 0. Okay? Can or not? Shall we take a